Started, and today we'll start with Nathan and pass up.
All right. Okay, I get the lead. Great. Um, so I think Venkat did peg me as definitely being a little more sympathetic to McElroy's approach. I will say I don't think I necessarily, despite having done a master's in applied mathematics, I don't think I actually have the academic chops to seriously critique news from a academic perspective. Um, I will say I think that a lot of this is a little overblown. Like it is notable that like McGilroy spends a lot of time praising New's approach. So I do want to get that out of the way. I don't think these are necessarily there's necessarily as much distance here as people like to make it out to be. But I think in the end, I think this is less like a question about programming languages or the right way to do something, and more of a deeper philosophical question about what programming is and how it relates to software development. And basically, is it an academic discipline? Is this something that we are, like mathematics, kind of discovering these new logical things? And I think that there's definitely a lot of truth to that. Or I don't even want to say it's like an engineering discipline. Is it a trade? Is it more like being a plumber? And I think we like to think of ourselves, software developers like to think of themselves as academics who are doing really interesting things, but most of us, most of the time, are plumbers. And from the plumbing perspective, it pays not to be too clever. Generally, the more clever you are, the more you're going to get yourself into problems. And so I do think that that's kind of the benefit of the McIlroy approach is that it's not being clever. This idea of we just have Tinker Toys, we're going to rearrange them in different ways. Now, you pay for that in a certain amount of efficiency. Like it does become more and more difficult to extend the pipelines like McIlroy has as your problems get larger, particularly in like distributed context. Um, but on the flip side, you can also identify bottlenecks in those pipelines and has the advantage of because it's Tinker Toys, you can just sub out things. You really only care about those interfaces. I think there is an argument that sort of the text stream interface is maybe not the best one. That's being a little more structured, might make more sense, but I'm not really convinced that um, general purpose languages are the best tool for simple jobs. Like in my own job, I've watched people spend a lot of time writing very, very elegant Python and Go programs to solve particular uh, issues we're having with doing a pen test on a particularly weird product. I've also watched myself spend a quarter or half a time and do it sloppy with Unix tools and a bash script. And on the one hand, I will admit their solutions are often faster than mine and more elegant and use less memory. But on the flip side, I finished mine in half the time, and it didn't take that much longer to run, so I still got the job done faster. And I think that's kind of the plumber versus the academic attitude. And I think maybe it sort of helps me here is that even though I had that, mathematical background, I never did computers in um, college. I have I like to semi brag that I almost flunked out of C++ twice. And the only reason I didn't flunk out was because I withdrew both times. Like, I am not a programmer. I am not somebody who deeply understands these concepts, but I can do things with the Tinker Toys. I can do I have done code interviews where I've created you know, sorting random numbers and things like that with bash scripts. I've also been told I'm the only person to ever try that. So it's definitely something you can do, and I recommend it. And I think it is sort of the difference between, what's good enough versus what is correct and elegant. And again, I want to stop, and I think McElroy would agree with me here that this is not to say that they're mutually exclusive. Again, bottlenecks form in these pipelines. The value of the pipelines is they're fast and they're tinker toys. As you get problems that are more complex, you are going to need more special purpose tools. But the point is to kind of keep the tools loosely joined. And even in a lot of programming languages with libraries and whatnot, you're still sort of wedded to the interface with uh, those languages, rather than simply being able to reuse those tools in many different contexts, potentially within other languages. Yes, you have wrappers. I've worked with wrappers, but those tend to be a lot rougher in my experience than you would like them to be. So I think that McElroy's approach is still going strong, and I think that if you want the job, if you want a big job done beautifully, then you definitely want somebody who understands programming, and there is definitely a place for that, particularly in pushing the frontier. But if you just need to MacGyver that shit right now, like nothing beats small tools loosely joined. So that is my defense of McElroy. Passing up. To
So who's going next?
Yeah, Karthik, you're next.
Oh yeah. Um, I don't have much to disagree with Nathan. I think I agree that most things can be done simply by most people because, you know, ideally, and even ideally for me, I think most people programming should be something non-professionals do. That we're all doing something for our own lives, and you just do that, then McIlroy's approach is what 99.99% of people should be doing. I'm a professional programmer, and so I get hired to build things for that are going to be used like infrastructure by lots and lots of people. And so I'm, because of professional interest, I'm interested in literate programming. And so I think that was sort of the subconscious framing for it's implicit. I think it might be more explicit in the previous article that John Bentley refers to. So this is sort of a sequel. He's introduced literate programming in the previous article, and he's told the audience what it is. And then he's asked Knut, who invented it, to write an example program. So Knut is, it's very deliberately framed that way, that he's building infrastructure for millions of people to use. So it has to be really reliable. So he's concerned with a lot of engineering constraints. And engineering constraints, remember, are contingent on the particular time that they were in. And Knut was actually like, his habits probably go back to when times computers were even more constrained. So he's thinking in very detailed fashion about performance considerations. Where if you look at McIlroy's program, it just keeps the entire list of words in the document for much longer than it needs to perform that initial sort, which I don't know if at this time it was feasible. One strange thing was that at one point in his criticism, he criticizes Knut for only handling 10,000 words and not sizing the array for the King James Bible or something like that. But then the sort is kind of inefficient with space as well. So that's a little bit of a disconnect. Anyway, I think that's where I'll leave it. Like, a professional needs to think about correctness and reliability, and it's hard. It's really, really hard. Literate programming helps a little bit, but honestly, I would estimate that I've never ever written a correct program. And so there's a huge chasm between even me and Knut. And so I guess most of us shouldn't be doing any literate programming, myself included. Um, literate programming is useful for if someone has a correct program, they can explain to someone why it's correct. But just putting it in the format of a literate program doesn't necessarily make a program correct. A few months ago, I went back to an old chess book that I learned chess from. And, it was kind of nostalgic. But when I went back to it, I found mistakes. I was like, I used to read this uncritically before because it was written like a book. It breeds confidence. I think literate programming is a little bit like that. I think that's a bigger criticism is when you format something as a tech document, it looks so beautifully typeset that you think the words in it are true. And we could all bear to be more skeptical in this age. Okay, I'll leave it there.
Yeah, we usually pass up to the next person. So in this case, you would pass to Jenna. Okay.
Okay.
Yeah, thanks for joining, Kartik. This is fun. I'll be quick because obviously I'm not a coder. Kartik, I'm one of those people that wishes I could whip up my own stuff, but not yet. But the top mind things are this is a perfect example, I think, of the Eric Holnagel's the Etto principle, the bedrock upon much of modern life, which is the thoroughness efficiency trade-off. So quick and dirty scripting programs versus something that is meant to be big and the bazaar, the cathedral, rather. So how to know what to do when. Nathan's examples were really great. I'm also seeing a lot of people say, that one of the good things you can use LLMs for right now already is to write this quick and dirty stuff. And I actually even had success with that myself. I managed to suck down a whole bunch of GitHub markdown files and do some concatenation, and I felt like I had superpowers. And that code wasn't meant to be on a shelf for 100 years. What else was I going to point out? Oh, I agree with Hilla Wayne's piece that and this has come up too, but that he was framed. He was not trying to write something that was meant to be critiqued, and that McElroy got lucky that the thing they picked was very easy to code in Unix and that kind of concatenated Unix nice tricks. And that it wouldn't have taken much for it to be much harder. The last thing I'll drop the link is I watched a video a year or so ago that Knuth did a big dragon curve, a fancy math mosaic in his house. And I guess it's been a while since I watched it, but it had been in the house for a long time before he noticed that there was a mistake. So Kartik, your point about when things are fancy and perfect and pretty, it's easy to not judge them critically. And so it was a fun example of that. So I will now pass to our friend Ben.
Yes. So I actually want to take this in a slightly different direction. In that, especially when I was a grad student, I did a lot of coding, or handled a lot of code that was don't want to be too mean, but let's just say not bestly written and undocumented. So trying to there was a few thousand lines of C++ that was effectively running a simulation of some science stuff, and it was a few weeks or a few months before I really figured out what it was doing. And I mean, that's not the first or last time I've had to slam my head against either a program or a library or something, where I was trying to figure out just, what is this doing? Why is it doing this? Why does it keep giving me this strange result? And one of the things that I've come to the conclusion on is that, if you have enough print statements and enough slamming your head against the wall, you can generally figure out what a program is doing. And I'm not super special in that regard. If you look at reverse engineers and everything, they can it's effort, but it's not impossible. The thing I ended up wishing most, and the thing that I think, having digging into other people's code, reading libraries on GitHub, I often really miss what's the context of this? Not what is the program doing, but why did the programmer choose this sort of structure in the first place? Is this like what you're supposed to do for this kind of program? Is this, something that is made up? Is this standard? Is there like a reason why they're doing it this way that they're immediately thinking of and being like, oh, yes, I needed to do it this way because of problem that's known in the field XYZ. Let's take care of that. So this is the structure, solve that, move on. And if I'm not aware of that context, figuring out why the program is, what the program is doing is not good enough. I don't know, without actually talking to anyone or doing like research on the structure of these sort of general class of programs that I'm looking at. I don't know why they chose this structure, and I feel like this whole literate programming thing, various forms of documentation, everything seems so focused on what the program is doing. It's often very difficult to know why they chose that in the first place, why they made this structure. Uh, yeah, like and a lot of it is just like, if I could talk to them for 5 minutes, maybe this would all make sense. I'd be like, hey, why did you do this, and this? And they were like, oh yeah, that's standard. Oh yeah, it's a common library. I grabbed it off GitHub. All these, like, a 2 sentence answer would be like, oh, okay, and then I could go with that. But if I'm, oftentimes I'm touching code that the original's not around, I don't know how to contact them, they're busy or something. Suddenly, I can slam my head enough to figure out what it's doing, and without understanding why, it's hard to know, like, is it supposed to be doing this, or is this a mistake? And without lots of context, or that can be very hard to come around to. And I feel like that's not the problem people work hard enough to solve. And this is where all this is coming to. Right? People need to writing. I think comments should be much more focused on, like, the general context of why you're writing this in the first place. I try to, when I write comments on my code, I try to do that. I can't say I always succeed, um, but I always try to, like, why am I approaching it this way? Why did I pick this out of all the possibilities I could have done? And I feel like that is sort of the thing that I most wish I had. And I'm not sure that the most methods of documenting code are necessarily the way trying to reach for that. I feel like they're almost just trying to make it easier to read the program as is, trying to figure out what it does, and that's fine. I mean, but that doesn't feel like the bottleneck to me. That's not the thing I feel like I'm struggling the most with. Anyway, yeah, I think I'll pass up to Anraj.
Yeah, I'll continue with what Ben said about providing context of why something was written. I think it's even if people try to write it, it's like, I think people might not actually know until it starts working why they have done it. So basically, like, you could write some post facto things, but what is actually happening while programming, I think, is like people are trying to find different ways, and they are choosing the reason on the go. So they are trying to figure out something on the go, and that's why I think it's sometimes very difficult to express fully in text why something was done. And even if you write fully something, uh, like, the context of the actual system you built might change when it interacts with the real world. And, like, even so, the comments become old when, like, you are clashing with reality. So that was something like, uh, what came to my about the context providing with comments or literate programming. And literate programming, I think it sounds good in, like, academia, where you have lots of time. Okay, you can, like, derive everything from first principles, go to the bottom of it, like what Donald Knuth does. But, like, in practice, generally what you do is what McElroy does. You, like, do plumbing. You uh, take various pipes or whatever tools, and then build uh, what a system that basically works. And but, like, I can see the value in it. So basically, like, so sometimes, if you are working in the automotive industry, or let's say the airline industry, you actually have to prove like what the program does and what the compiler does, or the output of the compiler. So there is a compiler called CompCert, which Airbus uses for their C program. So it's basically a formally certified. So there is like a lot of mathematics done, and I think it was done by Xavier Leroy, and he won some Turing Award for building that compiler. So there is value in what literate programming, or like really proving and being thorough with what. But even I think like even then you cannot ever really like pass on the context what's in your head, unlike unless you are like basically fusing your brain with somebody. Until then, like you are trying to express something, but like you might not be fully able to express what you are trying to do. And that's why debugging is so hard, right? Because like in debugging, like if you don't have the person who did the code, you are basically trying to rebuild their thought process itself. And yeah, and this also reminded me of like sometimes I actually think that nobody is actually knowing what we are doing. Like everybody is just trying to do something, and like people are saying lots of things, but like we are so early into this field that we actually nobody knows what the fuck we are actually doing. So and then Alan Kay has a lot of things to say about this. Like are we just tinkering with stuff around, or are we actually doing some engineering? And then he has a good YouTube video on like what computer science actually is, and like he compares it to tinkering. And then we don't have. He says that something like we don't have the actual structures to build large complex programs. So he gives the example of like how the arches were built late into engineering, and then we were able to build complex structures with arches and domes. But that came very late. So he says that like we don't have something like that for programming itself. And this also brings LLMs into the picture, like how LLMs are going to change programming, because it actually now the context is also shared with a model which is not a human and we don't understand, like how programming develops with that. Yeah, those were some initial thoughts, and then passing on to Anant.
Yeah, thank you. Um, yeah, I'm not a professional programmer, and to the extent that I've written scripts, Python or other sort of utility scripts in Fortran and other things, is for certain scientific computing ends. So it's always been very utility driven, so never cared for sort of elegance or like the sort of how good it looks. So just with that bias, as I was reading the article, the original eggs, I believe, not shell article, found myself kind of laughing and sort of thinking that yeah, like McElroy is seems like the right sort of orientation to have. Like, can you just do things to get things done quickly? But I did share the sort of the ACM paper. I didn't get a chance to read it fully, but I shared it with GPT, and I was trying to ask how the arguments in those papers has evolved in the programming paradigms since like in the last 20, 30 years. And it seems like a lot of Knuth's literate programming philosophy, so to speak, is sort of seeded the ideas of like Jupyter notebooks and all the other sort of notebook environments where you cannot have comments and executable code in line, so you can follow the thinking of that particular program. And since I haven't really tried to, well, to some extent, I've tried to debug some professional codes and things like that, but uh, to the extent that I've tried to follow codes written in Jupyter Notebook type environments and with the inline comments, I found it to be very useful. So for what it's worth, this seems like some threads of literate programming that's evolved in some aspects, like especially in like some data science and similar applications. Um, yeah, the last thing I was going to say was like, yeah, how is this going to change with the LLMs in the loop, so to speak? I did try for fun the visual Unix scripts to see if I can, on my Mac OS, to see if I can give it a file and see if it works, and it works. And I actually ran into an issue. I have a special character, and I gave the debugging. Well, I gave the errors to an LLM and asked it to fix what the error was, and it gave me correct. Yeah, it gave me a corrected script, and I put it back, and it worked fine. So that was fun. Uh, but yeah, it's to sort of to think about how LLMs in the loop is going to change programming, especially uh, low-level plumbing. That's interesting to think about. Um, yeah, had one more point I forgot, but I'll pass it to Venkat.
Yeah, so I took the two links and the original ACM PDF and put it in Chat GPT and started asking it about how they interact in practice in creating larger scale, persistent computation environments. And that was an interesting direction to take the discussion. And I was trying out various ways of synthesis, and I suggested one metaphor to it, which it seemed to like, which is that you can think of Newtonian Fabergé eggs as kind of like prime numbers. They correspond to things that are hard to factor or like impossible to factor technically. And the metaphor there is if you have a programming problem that fundamentally doesn't fit the highly composable passing handles to text streams around kind of approach of Unix philosophy. So it's not a plumbing problem. Then probably the best way to work on it is just try to create a Fabergé, industrial strength Fabergé egg for that problem, but write it so well and with like so many efficiency gains that it is worth it for any Unix plumbing to wrap around it, right? Because yeah, people have already pointed out that there's like an efficiency trade-off in doing things the Unix way, but I think the degree and level of the efficiency trade-off matters, right? Like sometimes if you're doing like, I don't know, a small pile of words and you're doing something like this, the efficiency losses and gains don't really matter. If you're trying to write the most efficient and matrix multiplication kernels for AI, and that's going to be like stressed at like gigawatts of energy worth of compute, you'd better make that the most efficient thing possible. So you can think of the Fabergé eggs as the prime numbers sort of like studied through a production infrastructure, and everything else is composite numbers, which you can think of as put together with loosely a Unix philosophy. It doesn't have to be throwaway shell scripts. It can be more enduring and like more battle tested and like robustly constructed. But the fundamental philosophy is small building blocks plumbed together and composed in various relatively flexible ways. And there's also a time component, right? If you create and embed a Fabergé egg into a complex production infrastructure, chances are it's not going to change very often. Like it might even last generations, right? Like I think Linpack, for example, which is used in supercomputing test suites, that was originally written in Fortran, and as far as I know, a lot of people still continue to use the Fortran version because it's like a bunch of like highly optimized linear algebra code things. Nobody has tried to like rewrite Linpack significantly, as far as I know. So that's kind of what I mean. So it gives you enough advantages in like elegantly crafted codes that it's actually worth trying to keep rewriting the packages and wrappers to embed it into more shifting environments. And the more shifting environments, they kind of live in, it's like, the Stuart Brand space layers approach. So you can think of the Fabergé eggs as the slowest changing level. Everything else kind of like changes at various rates. Maybe you have like a package management pipeline that keeps updating stuff. Some things are updated in reliable ways, like Airbus control software, like Anurag was talking about. And as you go further up to the fastest changing layers, you end up with like crappy shell scripts that need to work once, and they might be buggy and not work in all the cases you might need the script in, and you might just throw them into like a little script recipe book repository, and anybody else who wants to reuse your Unix script is probably going to have to like at least eyeball it to make sure it actually works for the new thing, or maybe tweak it a little bit. So I haven't done much of it, but as I understand it, the culture of using and reusing shell scripts, so not the individual utilities at the Unix level, but actual shell scripts that use those utilities with piping and stuff. That culture is very much improv modified type culture. You don't randomly take somebody's gist script and use it blindly, even though we are starting to do that now with LLM stuff. But in general, you at least you use it in an aware, conscious way, right? So there's like this strange effect of the most enduring infrastructure that lasts for decades has these long-lasting Fabergé eggs in the middle, and then these base layers of changing code, and the fruit fly level changing code. It gets enough live attention that it actually contributes to being the glue of the changing system. So that I thought was kind of a good metaphor for understanding sort of the win-win combination of these two things. The other thought that came up, shared this with another friend of mine, and he pointed out that, yeah, just like one of the articles says, this particular test problem was highly optimized to text stream processing. And for example, even if you shift to like another common type of class of problems like image manipulation, already it makes more sense to move to a pixel buffer and not do straightforward serial type computation and like stream passing type stuff. So even there's like a spectrum of text passing is very highly optimized for the Unix philosophy. Maybe something like image buffers, you can still pass things around. You can have like a chunk of like two-dimensional memory, and you can pass a pointer to that around to different little utilities that work on the image. In a way, a lot of AI, I think, kind of works that way. Uh, but the spectrum now is closer to the Fabergé egg, and you keep moving, and as you get to like, I guess, really complicated and entangled data structures being fundamentally the right way to represent a problem, then you get to like full-blown Fabergé egg, maybe something like that. But yeah, overall, I think in reality, if you look at the computational built environment, I think what you'll find is a 80 to 90% composite, vaguely Unix-ish code that's put together through plumbing, but lots of Fabergé eggs embedded throughout that do the really hard parts that need to be done extremely efficiently. Anyway, so that's my thing. So we have 8 minutes left. Floor is open for additional comments.
I think the only thing I'll say is those Fabergé eggs that you describe as like these hard centers of our infrastructure. There's been like decades of attempts to make them reusable, so you can take one from one context and transplant it somewhere else and have it just work, and that just never happens. You always have to open up the Fabergé egg or create a new one.
I think the LLM question is really an important one. Like I'm thinking of a spectrum of like how much knowledge and effort it takes to like work on code. And if the Fabergé egg is the hardest, where you kind of have to like crack open a prime number and rewrite it, maybe, then Unix plumbing is somewhere in the middle. Then like no code, low code is like to the right of that on the spectrum, and the far end of the spectrum is basically an LLM vibe coding loop, right? You just give it a problem and then keep plugging the error messages back into the LLM until it works for your case. But who knows what the code is overall, unless LLMs get better at like understanding the broader context better than the human programmer does, and making it more robust than the human realizes that they should probably be asking for.
I think there is maybe a little bit of something to that. I think one thing that was something of a throwaway was at some point in the article, McElroy makes a comment about whether you're sort of your primitive here is sorting or tabulating, and that the sort it's probably easier to go from sorting to tabulation than the reverse direction. So to a certain extent, like tabulation's like the more natural way to think about the problem, but sorting is kind of the more natural pipeline. And there's a little bit of like thinking like a machine versus thinking like a human to that. Like we have a lot of we have a lot of wetware that's doing a lot of this stuff in the background that we're not really aware of, and the machine is not like us. And so there is sort of like the Newsian approach is very much like, how do we think like a human in this context, and then get the machine to do the thing. One of the things in grad school that, like, I think the big thing I took away from it, and maybe it's just because I was really into analysis, was I got like this idea of like trying to think of how problem classes were like other problem classes at a very abstract level, and then pivoting between them. And so I do sometimes wonder if one reason, like I think there's probably three reasons why it is hard to repurpose things. One is that the problems are genuinely like just different enough that it's hard to port things between contexts. I think another one is efficiency. Like a lot of these problems, like you need something that runs in an embedded environment or has very little downtime, or works under a set of constraints. And as you become more and more optimized for that set of constraints, it becomes harder to port. A lot of these very central things in our infrastructure, they're like giraffes, where Unix tools are more like mice or rats. Like they're just sort of these like generalist things that they kind of live everywhere, but they're not like you could strip it. A whole bunch of rats could strip a tree like a giraffe, but it would take them a lot longer. A giraffe is just a better form for that, but it becomes very hard to go from a giraffe to a rat. But I also do wonder if some of it is that we are still sort of very enamored with trying to think like people. And that part of that issue is we write programs that do things the way we think rather than sort of what is natural for these primitives. And like, I don't know, I mean, I suppose the entire point of computer science education is to get you out of that set. But I also think there's a lot of cultural drives where we don't want to give that up. We don't want to give up our humanness. We want to make the computers more like us rather than us more like the computers. And I wonder if that contributes to some of the difficulties as well. Like obviously you're not going to ever get over some of the efficiency aspects and just being like the specialized Apex program. But like, yeah, I don't know. I'm not sure I really had anything beyond that, but I just wonder how much of it is also like how we think about things and how we approach things.
Yeah, that makes me think of all the people trying to like come up with completely new algorithms for solving stuff that are almost the opposite of literate using AI, right? Like chess or Go strategies that human players could never think of. And there's like people trying to come up with chip layouts and matrix multiplication programs that are like weird to humans because they don't. It's not even that they're not presented in a literate way where humans can understand them and kind of read them, but they fundamentally represent approaches and attacks into the problems that, I don't know, for whatever reason, the human brain never thinks of. So maybe in the long term, perhaps literate programming is kind of doomed if more and more code is written by AI in ways that are like fundamentally anti-literate. I don't know, maybe that can happen.
Or maybe
Anyway.
you see a resurgence in it. Like when you have something like that, it becomes much more important to understand why this works, because then because we can't just look at it and understand. And so that documentation. And I will say, I think it's kind of interesting that I've been reading more stuff about like people who are trying to use LLMs like in a practical sense, and also I've encountered some stuff with clients in my work who are trying to do this, and it is interesting that a lot of people seem to be converging on um, this idea of like essentially going from being somebody who writes code to somebody who writes very, very good spec documents. And so I do wonder if, you know, does do LLMs mean that for a lot of us, our future is much more word salad and shape rotator? We're much more going to be writing documentation for the machines than like actually coming up with the solutions per se. But then that documentation becomes much more important both for the machines and for us.
Any final thoughts?
I want to just jump in to say, sorry, Peter Barker. I helped the EF produce the physical volume of all of the Pectra code this month ago, and I feel like I'm Forrest Gump. I was trying to figure out how to typeset with colors, code coloring, all the code into InDesign, and that's when I had my little wins with pulling the text down. And one of the big questions was to my colleague Josh Davis at the EF are we going to do this again, or is this a one-off? Because it would change, how I would go at. So even at my level, these questions just don't go away. Efficiency, thoroughness, trade-offs. Anyway, just a fun little report.
All right. Thanks, everybody. We'll be back next week. And next week, I think, is Anuraj's Ethereum track again. So see you next week.